Right, so we're back again. I don't really know what this video is going to be about so much. We're just going to have a play around with this a little bit more. So last time I tried this with this ULN 2803. Is it the 2803? Yeah, that's right, it's the 2803. I kept thinking it was a... So the 2003, I think is the one, has the 7 outputs. This one has 8. Or 8 inputs and outputs. They're not really inputs and outputs, and that's the important thing, because this is open collector Darlington array, transistor array. I was going to talk about Darlington transistors, but there's a kind of like a diagram. Basically, if you don't know what they are, one transistor feeds into the other transistor. So as you increase the current going into here, then the current going through here into here is also increased, but at a greater point. And that goes into here. So small, basically, it just ups the amplification. So this is the output transistor here. So this thing here is just, but from my point of view, all I care about is that if I put in a sufficiently high current, that will turn on, or I can use that to, not turn on in this case, but to pull the output to ground. Or to pull that pin to ground. To pull what's ever going into here. So I probably should have drawn a diagram. That was the thing I should have done. So remember, so here's my load, and this is where I go, oh my goodness, nope, I'm going to draw that, and I'm going to draw alright. So that's my transistor, and this is my load, and so this is my common emitter configuration thing. But when I put enough current into here, then all the current will flow through here. But when I'm not putting any current into there, this doesn't have a path to ground, and that's what's kind of what I'm trying to focus on here. Because this is the way these things work. So this is all just for this thing. Is that there's only so many pins on this thing, but there's, you know, 5 times 7 of these, so there's 35 LEDs on this, but there aren't 35 pins. So you can set the rows, but only so you put a positive voltage in for each row, each LED, well, on a row, but it's only when you pull that column to ground that it comes on. But if you pull all the columns to ground, then all of them will come on, as we'll see. That doesn't really make any sense, but I'm going to use this to pull things to ground via an output from a 4017. So it's going to go through, the idea is you go through each row, you set up the outputs, so you set up what these pins, what that row should have, so whether that should be on or off, on or off, on or off, and then you pull that column. It's a bit hard to talk about this. That's not how it works. Maybe that's why I keep thinking about this wrong, because I keep thinking about rows and columns. No, these are going to be the rows here. So really, you should be looking at it like this. So, well, that's the trick here. You see, right? I'm talking about rows and columns because it says R's and C's, but it says R's and C's because it's rows and columns. Look, we're going to work this out because I have this picture here. But anyway, first thing we're going to do, this is my picture that helps me, which is more useful than looking at that thing. But, so tonight we're really going to work out the wiring for this, because I'm quite keen on actually soldering these things up. I just couldn't find the things that I wanted to use to hold these onto it's going to go on one of these things. But I want to use the header lines, and I don't know where I put the ones that I want, because the ICs that are going to control it are probably going to go underneath these to make it easy, or out of the way, because they all have to be stacked together, and that's the only way I think I can get them all on one board. I'm pretty sure I can get 3 in a row on one of these, and it will be fine. But first, so what I did last time is my mistake on the ULN 2803 is I was just confused by this whole common. So here's a little picture of the common thing, and I think I put the positive voltage on there, but that actually makes it not work at all. because of this thing here. So basically the common stuff is all to do with you if you're using a load that has an inductive load, and it's sort of like to fix up the inductive kickback or whatever the term is. But if I make this a positive voltage, I think if this is what happens, yeah, then the output's always going to be high. And because I was feeding with the output, in this case is what it's connected to, if I was feeding it in from high, so what I originally had in the last video was I had this, and I had my little LED thing. There's my little LED, so you can see that. And that was going into the ULN2803 into the transistor. So even though it's a Darlington transistor, we're going to draw it as just a normal transistor. And so the input that you're doing is the voltage that's going on here. So B is the base for here, and C is the collector for here. So I was putting in the collector in here, and then that was going to ground, and I thought that what would happen is if I put in a positive voltage in here, then this would create a path to ground, and because we're going from the high voltage down to the low voltage, this would all turn on and that would work. But if you look at what happens here, I think, so if I had a positive voltage going to the common, which is what I had, and I won't be going to that. Why would that will happen? Well, I think so. What would I be changing it? I would be changing it so that the actual circuit looks like this. I think it's hard to do this upside down. No. It's possibly that. Well, I don't know, it doesn't work. But the point is, you don't need to connect the common thing at all. It's too late for me to think out why this doesn't work. But I'm pretty sure it's there. Because they had a positive voltage there, then the LED will always be on, is what happens, or it'll always be off. I think it's always on. This still doesn't make any sense. And then you would have that going from ground through there and through there. I'm surprised it worked at all. Well, it didn't really work at all. So I will show you how it does work if I don't break this too many times. I'm really going to break this. I went and bought another 18 of these off the same person that I bought the last lot of. So they're not wired up at the moment. So let's just do this. So the first thing we have to do is get out my picture of my, I'm pretty sure I haven't broken any of these. Oh, for goodness sakes. Okay, well, let's leave that over there for now. I've actually been soldering up my Pong board, my one-dimensional Pong in 2 dimensions that I started a long time ago. So that's actually we're going to continue with that. I just got really stuck because my prototype is a giant rat's nest of a thing, and it's hard to work out where all the wires are. So I'm now making up a much nicer version. I feel like I just sort of made this non-child friendly now. Version of the thing that I was putting, and so that it's easier to continue on with. But the programming is kind of already done. But then I keep thinking about how is the game going to work to be fun. But I've got these really nice buttons, so I have to also build a case to go with it. So anyway, so this pin is pin number 9, and it's going to ground, so that's good, with a very, very long wire for the job. I'm going to make it go over here, so it doesn't look so silly. And we'll use, what pin, I think this is a 1000, I haven't really got my resistors ready for this, have I? Didn't really think this one through. I think these are 1000, these are 1000 ohms, these are fine. So that one is going to go to the positive voltage, so the voltage from my base, so we're putting in 5, and then we've got a 10, we've got a 1000, a 1k going into there. Is that right? 1k. Yes. I'm getting better at drawing things upside down. And I'm getting better at using my left hand for everything. So, like, because of my RSI problems, I now use my left hand for the mouse when I use my right hand. So that's quite exciting. And we don't have to plug in. There's no positive voltage going into this because it's just this part here. So we're now going to why are we using number 8? We're using base 8. So this is 8 of these transistors together. So that's nice. And then we will put this one here, and we'll put the positive voltage with this wire because it's red going into there. So it's not crossing over. And then we'll use another resistor. So it seems kind of pointless if you're just going to use the 1000 ohm resistors for everything. But it's all about controlling it, and it's all about the fact that these things can take a fair bit of current going through them, and that's all that I really care about. Also because, well, the way that the 4017 is going to work is it's going to be outputting a positive voltage, and I want that to turn a line on, but I can't use it to turn a line on. I can only use it to turn a line on if I'm pulling it to ground. I'm pretty sure, I keep going through this in my head that this is how this one works. So we'll find out in a second. Hopefully. So hopefully now when I turn this on, the LED will light up, and when I take this transistor away, the LED will turn off. So it's on, and if I take that away, it goes off. On, off, on, off, on, off, on, off. And if I take this one and I set it to ground, it also stays off, which is how it should be. So if I pull this to ground, then that won't turn the transistor on, and so the LED stays off, which is exactly the behavior that I want. And if I wanted to use the common thing, so what did I do? If that's what I must have done. I must have put the common to the negative thing. That's what I was doing last time, wasn't I? So if this is negative, then basically that will always stay on. So if I put the common to there, and then I can take that off, this is what I had last time, the LED just stays on and nothing happens. Because it's not even going to go through the transistor, it's going to go around that path, through here and down to ground. And if I put it on here, what happens now? It works fine, which is the way it should work. But the good thing is, if I had like an inductive load on this, and then I turn the inductive load off, then that's just the way. We'll go through that at some point, when I'm in a mood to explain it perfectly and have tried it and have practiced knowing everything about it. Which I have not done tonight. So we'll talk about that later on. But if you don't care about inductive loads, I don't think you have to worry at all about the common on this trip. Okay, so now we've got that. Now we have my other piece of paper, which I carefully drew, which is the what the various pins. So I think we're going to work out which way around is this picture. So it does have these little indentations on the side, and that tells you which way around it is. So this is 1 to 10 at the bottom, and this is 11 to 20 at the top. So this is now orientated that way, which is not much use, right? Because wait a moment, I can turn this around. I was going to say, because I've got to turn it around over there, but I don't. I can in fact turn it around here. So if I keep it exactly the same way round, so I have to do this because I'm not entirely sure I understand what is going on. And if I'm going to solder it up, and if I'm going to go through with this silly plan to make a Tetris game, which it could just be any game which has 4 colors, 3 colors, 4 colors if you count black, or transparent. Which is always one of those things, like on old school computers, sometimes they'd have 8 colors, but one of them is transparent, so they don't really have 8 colors. Well, they do have 8 colors because transparent is usually black, but they don't really have black as a color. It's just like when you don't have anything in the way. So I think that, how come it doesn't feel like it's lined up properly? It feels like I've done something severely wrong, and because it's not straight. Why is it not straight? I'm surprised these things just haven't broken off. Like, I've done this so many times. The first time I put it on, it was really hard, and then I'm like, oh, I'm going to break it, and then it's just done it. So that's why making up a soldered version of this. So I've been quite keen on soldering now because I've got a nice setup for it, and it's not this desk. and it's right next to the window. It's well ventilated, and it has a television in front of it, so I can watch movies at the same time, which is good, because that's what people like to do. Alright, so the first thing I'm going to do is I'm going to try and get one entire row to turn on. Well, yeah, one entire row that way to turn on. And so I'm going to do this, and I've also realized these are 5x7 and not 5x8. So it's going to be a real cramped Tetris. So it's not only not 10 wide, it's not 8 wide, it's actually 7 wide. Which should be fine if you're making old school VDU, visual display unit characters, which always seem to be, although printers were 5x7, which always seemed like a strange number to me. And it's annoying, right, because it's got these two non-connected pins. And it's like, well, you could have put in another row, and you could have used those two. Could you? Maybe you couldn't. Yeah, no. You could have had like another. You could have used those for something. You could have had another row or another column, and it would have been fine. But no, you've got these two non-connected pins. And I've gone and forgotten it yet again, which is the right way around. Where's my picture? All right. So that's 1 to 10 over here. So I need to put, and this is where it's going to get tricky because I don't actually know which pin. So 1 and 4. I'm going to need a lot of resistors that I don't have right next to me. Alright, we're going to use these because these are right next to me. A whole bunch of old school, rather small 56K. So these are not going to be bright at all. But this is actually what I've used in my Pong game, because the LEDs that I've used are really, really bright. So I've gone and used this tiny well, I can't, as I can. Okay, I'm going to put them here, and I'm going to go make a little line of these things. So the nice thing about these is that they're real small and then they fit on the desk. Yeah, they're really bright, and so I have to use a really high resistor because they're just so gosh darn efficient that it's just ridiculous. You can't play a game of like staring at like LEDs going backwards and forwards if they're that bright. Your eyes will have pain, and pain in eyes is not a good thing, turns out. So definitely going. Then I thought, well, I should just put it in some kind of potentiometer or something, so that I could change it over time. I'm not doing this very well. I should be doing this nice and stylish. I've gone and moved my the best tool in the world, I think, is long nose pliers when it comes to this kind of stuff. They're on the other desk. So I'm going to need 7 of these, and we're going to do it the way it says in the book. So I've gone and done it wrong again, haven't I? I have. It says I have to put the resistors. No, this will be fine. So the only thing is that I have to have the same resistors for both types of LEDs. So the current will be different. But I don't know what the voltage drop is, of course, because there's 2 different LEDs for each one in here. One's the red one and one's the green one. I assume they have a relatively similar voltage drop, but I keep thinking there's no way I can't have one resistor for one type and then another for the other type. Right, so we need lots of wires for this. I better hurry up because this video is going to take forever. Well, we have one long wire. Is that actually 7? Oh my goodness, it was 7. I wasn't even counting. Okay, so that one can go there. So now they've all got 5 volts going in there. And then I have to put these little things. So I want to get them in the right order. So this one, we're going to go 1, 2, 3, 4, 5, 6, 7. So this one is 4. I think I'm starting at 1. So that should be that one. Alright, and this one here is 6. So that's that one. Alright, and then we're going to need, so this one over here, I don't know if this is actually, I'm assuming, I'm just guessing, that can't be right, it could be right, is 5. I could just plug in, okay, hold on, I want to build the suspense. So that one next to it is going to be, I'm not going to build any suspense because as soon as I plug it in it's not going to work because I haven't got them lined up. Because I can't tell where the pins on this thing are because they're hidden. Where's my other pack of these things? Wait, we've almost got them. And then we need 2, which is over here. Okay, we're going to need the long ones. Alright, we'll just use these extra long ones. I've taken out too many. Alright, where is it going? Where's it going? Where's it going? Where's it going? So 2 is, I'm going to guess this is 2 here. Well, at least this way I can get half of them right, if I can get one side lined up. And then, we've already done 4. Oh, that's right, 4's got 2 connections. 4's a bit strange. 4 has 2 different connection points, just to waste more pins for no reason. So I don't know if they have to both be, I don't think that, why would they have to both be connected? I don't know. And then 3 is this one. So that one can go there, and I think we only have one more wire to put in. I feel like that one could have been a short one. That was a bit over the top. And then that one goes there, and this one will have to go to 1. So, does that make any sense? So that's the pins. Right, it does. And now we have the last thing. So I want to do, so this meant red for column number 1, or row number 1, or whatever, whichever way around you want to look at this. So for line number 1 is red, so this is number 9, which is the one that should be next to here. So if I put this to ground, something should turn on. A whole lot of things should turn on. And you can't actually see that because it's very, very dim. So I feel like I probably should not have. Can you actually see that? Okay, we'll have to go dark style for now. So 56K doesn't work as well as it does with the little white ones that I was using. Like these things here, which you can't see because it's dark. Man, these things are bright. Alright, so we've got one wrong. And it happens to be pin number 4. The awfully suspicious pin number 4. So, which one would that be? Well, I've got pin number 4 coming from here. So, if I move it around, maybe that's all I've done. It should be 2 across from this one. I'm actually surprised most of them work. So that one? Hey, they're all on. There we go, we got that right. So now if I take out, let's just see if we've got them in the right order. Number 1 is the yellow wire over here. So if I take out that one, this one goes out. And number 2, which is the orange wire over here, if I take that one out, you can't see anything, number 2 goes off. So it looks like I've actually sussed this out and it's all gone according to plan. But now we'll put that one back in. So now we can change. So this is red. They do go in pairs, so that's quite nice. So red and green for row number 1. So if I go red, green, right, red, green, red, green, red, green, and if I put another one in, alright. The good thing about them being so low, oh, it's still doing that thing again. I did it wrong, didn't I? Because they've only got one. How am I supposed to do this? Oh yeah, that's right. You can't do that. You can't mix them together like that in this sort of process. So what's going to happen in the end, if you want to do it in a way that you can program it, because what's going to happen is you're going to have to go through and light up one row, do the output for one row, but in one particular color, and then change the values and switch to the next row the next set of colors. So start off in red, put out the outputs for red, change them over the green, change over the green, then move to the next row down, which is going to be next line, so 3. But we can actually have multiple, we should be able to have multiple lines. We're not going to overdo it by, that's not what I wanted. It does actually go a bit dim when you do that. Oh no. I can take that off. It's really making it hard to see anything, isn't it? So let's just go with 4. So 4 with the red should be here, and then if I take that to ground, oops, I turned this off. It's kind of struggling. It goes to quite dim when you do that. You would think if they were 56k, I wonder how much current they're drawing. 56k, no, 5.6 ohms. I'd have to work that out. I didn't actually expect to be able to, that it wouldn't be able to display those. You can see that they're there. We can get the red ones. Let's get the red ones. I'm a bit, oh no, that's the non-connected one. So that's red. That's row number, that's 4. That's not what it's, those are that's supposed to be non-connected. So if you attach it, that's the problem, kind of. Whoa. Well, that kind of makes sense, I think. Oh no, because they're going to go through there, right? Oh yeah, well that makes sense. No, that makes sense. That's why it's going to be dimmed. But that's okay. It's going to be dimmed because they're all going through. Each one of these will go through the one resistor. And so if you've got them going to 2 different paths to ground, then that current is going to be halved. I don't know, I have to think about this and explain it for the next video. But anyway, I'm going to go back. No, I'm not. I'm out of time. We didn't even get to actually try using this thing. So I wanted to actually control that. We got a couple of minutes to do this. I know this thing off by heart now. This is the ground connection. I'm using the wrong one. So that's going to ground. This is going to be my on and off thing. That's going to there. It's going to be plugged into there. And then instead of this one going, it's going to go to there. Alright, turning the lights off for 54 seconds. So now I can turn this line off by plugging in the connection onto the base here. So this is going to be my output on my 4017, and it's going to go through and turn on each of the lines. So if I actually had time, which I don't because I've got 36 seconds left on the clock, I'd plug all of the rows into this thing and then undo them like this. So there's going to be 10, essentially 10 rows, because there's 2 different colors for 5 different rows. So I'm going to need 2 of these chips to get 16 outputs so that I can cover all 10. But hopefully I can use the other 6 outputs for something useful. But thanks for watching, and hopefully when I solder this up and we start working on the game, it will be lots of fun and it will make a lot more sense. And I won't make silly mistakes. So thanks for watching, and bye.